Okay, I think we can start. So, group 4, we have started going through topics from section 4, production and operations management, if you remember. And the first topic that we covered in a previous class, that was comparison of the terms effective, efficient, and productive. If you recall, we learned how to draw a line between the terms effectiveness, efficiency, and productivity. Right? So, just a quick recap, just a summary, and then we'll continue with this. This is section 4. It's called operations management, project and operations management. And in our previous class, if you remember, people who attended the class, we tried to draw a line between 3 very commonly used terms: effectiveness, efficiency, and productivity. And as we had a discussion regarding this, that all 3 terms, effective, efficient, and productive, all 3 terms are used interchangeably. Usually, we should try to draw a line between these 3: effectiveness, efficiency, and productivity. But usually, we apply these terms in such a way that they're almost used interchangeably. So the very first topic that we selected in section 4 was this one. And if you strictly follow the curriculum, this is the first topic in section 4, otherwise also. So what we learned was that effectiveness means having the ability to make the right choice, right? Selecting the most suitable option. And I quoted the example of McDonald's, that they started serving breakfast to the customers, and this has proved to be a highly effective decision. Then this was compared to the term efficient, and being efficient means having the ability to use the available factors of production in an optimum way. I'm just revising what we covered in the last one quickly. So the term efficiency, this basically means that a firm has the ability to use the available factors of production or the available resources in an optimum way or the best possible way. And usually being efficient means being, having the ability to reduce wastage, right? Just try to remember, being efficient means having the ability to reduce wastage, right? So in this context also, an example from how McDonald's runs its operation, that was quoted, that they have developed a fat fryer which has enabled them, McDonald's, to reduce the consumption of oil by almost 30%. So that is huge, 30% reduction in the consumption of oil in case of McDonald's, keeping in view the quantity of French fries they must be preparing on an annual basis. So we can well imagine that the amount of money that they have saved by adopting the strategy, right? So basically, the point is that being efficient means having the ability to reduce wastage, or being efficient means having the ability to use the available factors of production in an optimum way. And the third term that we learned last time, that was productivity. And I also explained that productivity and the term that was just discussed just before that, productivity and efficiency, they're linked. So productivity is just a way of measuring how efficient a business is. And there's a formula to it also. Productivity is equal to output divided by input. And it is further classified into labor productivity and capital productivity. So this was just a summary of what we learned in the previous class, right? This is section 4, operations management. And the first topic that we went through, that was comparison of the terms effectiveness, efficiency, and productivity. And we just tried to learn what the difference was with the help of appropriate examples. Now let's continue. An extremely important topic in section 4, that is called operation methods. Very, very important topic. operation methods, and this may also be termed as production processes, classification of production processes, or simply types of operation methods, right? So we have to keep in mind that when you are trying to differentiate between different operation methods, when we are trying to differentiate between classification of production processes, there are two terms which are going to be used repeatedly throughout. Those are standardized and non-standardized, right? Keep in mind the two terms, standardized and non-standardized, and we need to have an accurate idea about what the difference is between the terms standardized and non-standardized. What are we discussing here? This is the next topic after effectiveness, efficiency, productivity. The topic is called operation methods. It is also called classification of production processes. There are 5 production processes or 5 operation methods that we are going to discuss here, right? But in order to understand these operation methods properly and fully, we need to know what the difference is between the terms standardized and non-standardized. Because throughout these 5 production processes that we'll compare, these terms are going to be used. So just remember the word standardized. It represents such a production process, a standardized production process, through which the same product is manufactured in a very large quantity and its identical units are manufactured in bulk, obviously. What is standardization? A standardized process is the one which leads to the manufacturing or the production of a very large number of identical units of the same product. That is called a standardized product. People joining in, we are discussing the second topic in section 4 in operations management. This topic is called types of operation methods or production processes. And we are just trying to differentiate between the terms standardized and non-standardized, right? So standardization means that there's a production process and it leads to the production of or the manufacturing of a large number of identical units of the same product. The same product is being manufactured, usually with the help of machinery, in a very large quantity. That's a standardized process. So these pens that you're using, these are standardized products because millions of similar identical units of these pens were manufactured with the help of machinery, right? That's a standardized process. Soft drinks, pens, markers, anything that is produced, soft drinks, in bulk, in a very large quantity, and identical units of the same product are manufactured in bulk, usually with the help of some sort of machinery or equipment. Medicines, for instance, those tablets, those are also standardized products, identical units in bulk. Non-standardization, on the other hand, means that individual products are manufactured, individual units of a product are manufactured, one at a time, non-standardization. Individual units of a product are manufactured in accordance with the specific requirements of a customer. Such a product is called a standardized product, right? Sorry, non-standardized product. Non-standardization means when individual units of a product, they are manufactured. When we say individual units, that means one at a time in accordance with the specific requirements of a customer. So a non-standardized product is like a customized product, one unit at a time. Standardized is like a ready-made product. So non-standardized is a customized product when one unit is produced or manufactured in accordance with the exact requirements of a particular customer, one unit at a time. That is non-standardization. So these customized cakes, tailor-made suits, customized furniture, all these are examples of non-standardization, right? So you've understood the difference between standardized and non-standardized. Now, we're going to apply this as we go through different production processes or different operation methods. We have to learn a bit about the application of these two terms, standardized and non-standardized. So the first operation method or the first production process is project production. The first one is called project production, right? The first operation method, that's called project production. So what are the main features of project production? The main features are that project production, number one, is a non-standardized production process. Project production is a non-standardized production process, right? Project production is a non-standardized production process. I've just explained what that is. One unit at a time, customized. So project production is non-standardized, number one. The second feature is that it involves a huge investment. Project production, when I say a huge investment, I'm talking about an extraordinarily high investment, something involving billions. So these are the main features, right? Project production is the one which involves an extraordinarily high investment involving billions. And it is non-standardized, one at a time. So the best example of project production is large-scale civil engineering projects. Large-scale civil engineering projects. What is project production? In which we have large-scale civil engineering projects. You know, construction of civil engineering involves construction, obviously, such as construction of dams, motorways, airports, right? So that is project production, right? That's called project production. So what is project production? Number one, it is a non-standardized production process involving an exceptionally high investment, possibly billions. And you see in this topic, we are discussing operation methods here in section 4, and we're going through project production. And I was just mentioning this in this topic, you must remember and quote relevant examples, because in 5 production processes, there would be a bit of overlapping, there would be some gray areas. So examples are important. So for project production, which is non-standardized, involving billions, exceptionally high investment, try to quote the example of motorways, airports, large-scale civil engineering projects. That's number one. Operation method number 2. That is called job production. Job production. Right? The first one, that is project production. Number 2 is called job or jobbing production. Now, what are the features of job production? Firstly, job production is also a non-standardized production process, just like project. Job production, this is also a non-standardized production process, quite similar to project production. Non-standardized, as we have learned, something which is customized, something that is manufactured or produced one at a time, right? That's called job production. People who have just joined the class, we are discussing operation methods here, or production processes, which is a topic in section 4. And we've tried to learn what project production is. Now we are going through job production. So job production, I was explaining, job production is the one which is non-standardized, which means it is customized. One unit is manufactured at a time in accordance with the specific requirements of a customer. But the difference between job production and the one that we discussed previously, project production, the main difference is that project production involves an exceptionally high investment, possibly billions. Project production involves billions in terms of investment, right? Job production, on the other hand, involves a small or medium-sized investment. Job production it involves a small or medium-sized investment, not billions, possibly even, not millions even. So those customized cakes, tailor-made suits, that is job production, right? A customized cake is a typical example of job production that you place an order with someone and it is baked and designed, the cake strictly in accordance with your specific requirements. Does not involve billions, obviously, like project production. So that is job production. Examples are important. So what we've learned is that project production and job production both are non-standardized. But there is a difference in terms of the amount of investment involved. Right? Okay. Now, production process or operation method number 3. After job production, we have batch production. Batch production, BATCH. So batch production means that there is a standardized production process. Now, here's the difference. As you know, project production, as we just discussed, project and job, those are both non-standardized. Project production and job production, they're non-standardized. One at a time, customized. But this one, batch production, is a standardized production process. Batch production is a standardized production process, right? Which basically means that right at the beginning, I think we discussed this in detail, the difference between standardized and non-standardized. So standardized means identical units, production in bulk, usually with the help of machinery. So batch production is a standardized production process through which different versions of the same product are manufactured in batches. In batch production, which is a standardized production process, different versions of the same product are manufactured in batches. When I say different versions of the same product, this basically means the same product in different colors, flavors, sizes. That is batch production. This is in bulk. This is mass production. For example, soft drinks, juices, 1 million bottles of some cola drink, 1 million bottles of lemonade, 1 million bottles of orange. Or they have these packs of juices, 100,000 packs of mango or orange or different flavors, different sizes, different colors. These pens, these markers, all these are examples of batch production, right? When different versions of the same product are manufactured in batches, of course in bulk, it is standardized. We call it batch production. They are being manufactured in batches. Right? Like I was just doing a case study, different varieties of different types of, there was a producer of paints. So they were using, it was mentioned there in the case study, they were using a batch production system, which means that they were producing that paint in bulk, but those cans, of course, they kept on switching from one color to another. So that's batch production. Standardized, right? So obviously it involves machinery and technology. So that's batch production. So I've quoted the examples: paint, different flavors of juice, medicine, so on and so forth. Standardized. After batch, we have flow production. FLOW, flow production. Now remember, flow production, this is also standardized. This is also standardized production process, flow production. This is also standardized, right? But try to remember the word perpetual, because I was just explaining there is overlapping. So you have to remember certain examples or certain distinguishing words, right? So this flow production, it is a standardized production process, which is perpetual. It's a standardized perpetual production process. So the word perpetual, I hope we all understand what that means. Perpetual is non-stop. It's an ongoing process, non-stop. The machinery works round the clock. When the machinery works round the clock, maybe for a few 100 or 1,000 hours, it keeps on working, no disruption. We call it flow production. That's perpetual. The word perpetual means non-stop. The machinery works round the clock. There's absolutely no disruption, not even for a second. So the distinguishing feature as far as flow production is that it is standardized, which means the same product is manufactured in a very large quantity, and it is perpetual production, non-stop, without a break. So typically, I'm saying typically, not necessarily, but typically, generally, the term flow production is used in case of fluids. Generally, it is used in case of fluids. Flow production, the term flow production usually, it is applied in case of fluids. For example, an oil refinery. For example, an oil refinery, if you have an idea, it works round the clock. It works perpetually, an oil refinery. And of course, the nature of the product is such, it's an oil refinery, that you can't afford a disruption in the supply. So oil refinery would be a good example, right? In addition to an oil refinery, power generation, production of electricity, that is also flow production. It works, it has to be perpetual. It has to be non-stop, perpetual production. Or water distillation plants, they also work perpetually, so on and so forth. So we're just trying to learn what the term flow production means. This is section 4. And the topic is operation methods or production processes. And what we've learned is that in flow production, the machinery works perpetually. The machinery works round the clock. It is a standardized form of production. The same product is manufactured in bulk in a very large quantity. And the machinery works non-stop, perpetually. And it is standardized because it is identical. It's not something customized. The same product is manufactured in a very large quantity. Right? That's flow production. And also keep in mind that in flow production, usually, I've just mentioned that fluids, water distillation plants, oil refinery, production of electricity from water, that's a better example for flow production. Though there could be other products also, but the condition is that it has to be perpetual. You know, in many books you might find that, you know, when you're publishing something, if you have an idea, like newspapers, a popular newspaper, the press, it works round the clock. Even that can be categorized as flow production or labeled as. But typically, like I said, try to quote examples representing fluids. So we're done with project production, job production, batch production, and flow production. The fifth and the last operation method or production process, that is called line production, L-I-N-E, line production. So remember, line production is also a standardized production process. Just like batch and flow, line is also standardized. It's a standardized production process, line. And standardized, which means the products that are being manufactured with the help of this, they are identical units. But the distinguishing feature would be that in line production, highly sophisticated machinery is used. That's a special distinguishing feature of line production. The sophisticated machinery is used. High-tech machinery is used. Robots are very commonly used in line production. Use of robots is very common in line production. Right? So it's a standardized production process. sophisticated technologies involved like robots. And the best example as far as line production goes, the best example is manufacturing of motor vehicles, cars. Because as we all know, in car manufacturing, the use of robots is very common. Right? So line production, car manufacturing is a good example. Standardized, obviously capital intensive, use of machinery, etc. High investment, that's line production. Okay. So we've tried to differentiate between project production, job, batch, flow, line. Now, since we're discussing this topic, I would like to refer to a question which is asked very commonly, of course, based on section 4 and this topic. So let's quickly try going through that particular question, just to give you an idea, the kind of questions that can be asked based on this topic, very common. So, this is like the statement of a question based on this topic, operation methods. The statement is, the question is, a manufacturer switches from batch to flow production. Very commonly asked question. I think I've seen this maybe, more than a dozen times, I think. So this manufacturer, and you can find this in paper 1, 2, and 3. So manufacturer, he decides to switch from batch to flow production. Comment on his decision. I repeat, the statement is, a manufacturer decides to switch from batch to flow production. Comment on his decision, or to what extent do you agree? Whether it is a good decision. You see all this terminology, whether, to what extent, evaluate, comment, discuss. All these terms indicate that the pros and cons both have to be discussed. You need to discuss the pros and the cons. Right? So let's go through this. Let's discuss this. I hope you have understood the question. There's a manufacturer. Currently, he's using batch production. Now he's decided to switch to flow production. So we have to comment on his decision. What are the plus points and how can this possibly backfire? So as far as the advantages are concerned, first of all, flow production will allow him to maintain a high level of production continuously, perpetual. Flow production, it will allow the manufacturer to maintain a high level of production continuously, thereby enjoying major economies of scale. So when a manufacturer switches from batch to flow, he will start enjoying economies of scale. The average costs will drop because obviously the level of production is high. It is non-stop production. So as compared to batch, there'll be greater economies of scale. The average cost, the per unit cost will drop. Right? That's one factor that supports the decision. Okay. Number 2, flow production guarantees a high degree of uniformity in the production process. It guarantees a high degree of uniformity in the production process. Flow production guarantees a high degree of uniformity in the production process. Right? Obviously, the machinery works round the clock. It is perpetual. That's the basic point. So there's a high degree of uniformity. There's no fluctuation or variation in the quality standards. All the units, they're absolutely alike, identical. There's no variation in quality standards. Increase or decrease in quality standards, no. No variation in quality standards. Right? So that's another plus point, because in batch production, there is a possibility that the quality standards might vary from one batch to another. So in flow production, there's a high degree of uniformity. The same quality standards are maintained. Right? And of course, that's good for the brand image. Good for the brand image. There's no variation in quality standards. Good for them. Good for their image, credibility. So that's number two. Thirdly, when somebody switches from batch to flow, the workforce can be downsized. Remember, flow production is more capital intensive. Flow production is more capital intensive than batch. Flow production, it is more capital intensive than batch production. Right? The reliance on machinery is greater in case of flow production as compared to batch production. Both are capital intensive, but flow production is way more capital intensive than batch production. Basically, the machinery, like we've understood, the machinery works round the clock perpetually. You just need a few supervisors, that's it. There's no major active involvement of workers. So flow production is more capital intensive than batch production, because of which the workforce can be downsized. That's a plus point. The workforce can be downsized in case of flow production. And when we say the workforce can be downsized, we need to understand why this is a plus point, why this is an advantage. You see, it's not just about the salaries. Obviously, with the workforce downsized, the costs might go down and they don't have to pay them higher salaries around. They know that's only one part. But when the workforce is downsized, all the HR related problems can be avoided. When the workforce is downsized, all or most of the HR related problems, human resource related problems, that can be resolved or those could be avoided. And when we use the term HR, we've done this in section 2. HR is a combination of recruitment, hiring, training, motivation, discipline, communication, organizational structure. All this is HR. So all these problems can be avoided or resolved when you switch from batch to flow. Obviously, you don't have to motivate the machinery. You don't have to communicate with it. Motivation, communication. You don't have to discipline the machinery. So salary is only one aspect. So all the HR related problems, mostly, they can be avoided or resolved when somebody switches from batch to flow because the workforce is downsized. Then another very important point is that supports flow production, that supports the manufacturer's decision to switch from batch to flow, is that in case of flow production, you see, typically this production process, we've been using the term perpetually over and over again. This is recommended in case of products which are very high in demand, right? This is recommended in case of products which are very high in demand. I'm talking about flow production here. So we can discuss this as a plus point, and afterwards, because this is an evaluation-based question, we can discuss it as a drawback also. For the time being, we can add it to the list of advantages that since flow production is perpetual, it is an ideal production process in case of products which are very high in demand, and the products in the case of which one cannot afford a disruption. One can't afford a disruption in the supply. For instance, I quoted the example previously of oil. An oil refinery, that is an example of flow production. So oil is a product, as we all know, which is extremely high in demand, and we can't afford a disruption in the supply of oil or petrol. So flow production is an ideal production process in case the demand is very high. So that manufacturer who's switching from batch to flow production, if he's dealing in a product which is very high in demand, then flow production seems to be a good choice. So all these points, these 4 factors we've discussed, they support the decision taken by a manufacturer of switching from batch to flow production, right? Now the other side, since it's an evaluation-based question, whether you recommend this, to what extent do you agree? So we have to discuss the drawbacks also. So as far as the drawbacks are concerned, for someone who's switching from batch to flow, first of all, you see, starting, we can focus on on exactly the same point that we just covered, that flow production will be a disaster. It will prove to be a disaster if there is an unexpected decrease in demand. I repeat, flow production will prove to be a disaster if there is an unexpected decrease in demand. Because the prerequisite is, or the basic condition to be fulfilled is, the basic requirement is that if somebody switches from batch to flow, the demand should be extraordinarily high. Only then flow production will be fruitful, or it will be effective. Flow production will be absolutely ineffective if the demand goes down. Because you see, the machinery works round the clock, it is perpetual. Demand goes down, the machinery, of course, the machinery will continue to produce that item in bulk. So what would this lead to? A buildup of stocks. Flow production can lead to a buildup of stocks, which can be disastrous for a business. Demand is down, production is high. So basically it has led to a buildup of stocks. You know, that material, that stocks, they might be wasted. The certain products, certain material, it has a certain shelf life, it expires. There might be a shortage of storage space now. There might be a case of obsolescence when something becomes outdated. So flow production will be an absolute disaster. It will be very risky in case the demand goes down. So that is a huge risk factor. That's a drawback. Then secondly, if somebody switches from batch to flow, we should know that flow production is highly capital intensive. Flow production, it is highly capital intensive, as we've been discussing. It is highly capital intensive, flow production. And this means the capital cost will be very high. It is a highly capital intensive production process, flow production, more capital intensive than batch production, right? So this means the capital cost will be very high. The manufacturer, he has to keep in mind that he has to raise funds and he has to manage all that investment. The capital cost is high. And then maintenance is expensive. It is highly capital intensive, and taking care of the machinery, the maintenance, that's very expensive. If there's a breakdown, that's terrible for the business organization, because, you know, a breakdown means that getting the machine restarted, it won't be easy in financial and non-financial terms. So that's another possible drawback associated with the decision of switching from batch to flow production. High maintenance costs, high capital cost, right? Then thirdly, flow production, remember, in flow production, we just learned that the workforce is going to be downsized. And we discussed that as an advantage. But this could be a drawback also. The workforce is going to be downsized. When you switch from batch to flow, this can be discussed as a drawback also. Because you see, when the workforce is downsized, definitely there are going to be allegations against the company that they're causing unemployment. It is bad for their image, it is bad for their credibility, it is bad for their reputation, right? So when a manufacturer switches from batch to flow production and he downsizes the workforce, and he just simply asks his workers, you know, they have to be laid off. So that is not good for their image. They're causing unemployment. There might be allegations that they are not fulfilling their corporate social responsibility, CSR. So there are many pressure groups, there are many stakeholders that might be unhappy about it. The workers obviously will be unhappy, demotivated. The government might have an objection to it, that this company is causing unemployment. Maybe if they were offering some subsidies previously, they might decide to withdraw those subsidies. So that's an issue. And then maybe you can add one more point, last point to the list, that, you know, in flow production, there is no innovation, there's a lack of variety, and the workers who are left behind, who are managing it, they might find it too boring. But the machinery works round the clock, and the involvement of the workers, that's not much. So this might be somewhat demotivating for the workers, loss of skills, less involvement in the production process. There's no major innovation. So that can also be added to the list of drawbacks. So we can easily see that switching from batch to flow production has its advantages and drawbacks. And this is such an important question. I would say in section 4, by the law of averages, if you try and assess, the papers that we've seen in the past, last few years, I think from section 4, this question, the question which has the highest probability by the law of averages from section 4, that has to be lean production. That is going to be, by the way, our next topic, lean production. Most of the questions, I think, based on section 4, the highest probability of finding a question from section 4, I think that would be lean production. And in terms of probability, this is number 2. Batch and flow production, very commonly asked. There's so many past papers in which we see this question, paper 1, 2, and 3, that somebody switches from batch to flow production, comment on it. So this is an important topic. So we're done with this topic, operation methods, and we also selected a question from the past papers, and we learned a bit about how to differentiate these. Now let's start. Let's start discussing the next topic. That is called lean production, L-E-A-N, lean production. The next topic to be discussed, that is lean production. So there are some students who have just joined. We just managed to wind up a topic called operation methods. Make sure you revise it. We are on section 4. The first topic that we discussed, in the previous class on campus, that was the comparison of effectiveness, efficiency, and productivity. Today in this class, we've covered another topic from section 4, which is called operation methods. We try to differentiate between project production, job production, batch production, flow production, and line production. Now we're about to start focusing on lean production. This is the next topic. We'll have a detailed discussion on this, lean production, just the introduction in the remaining 10-15 minutes. The topic is lean production, L-E-A-N, lean production. Okay. First of all, you should remember that this technique, lean production, it has its origin. It has its origin in Japan. This lean production is a combination of a few Japanese techniques. Lean production is a blend of, it's a combination of a few Japanese techniques, which we are going to discuss one by one, which are used with the primary objective of maximizing quality and minimizing wastage. Lean production is a combination of numerous Japanese techniques that are used with the objective of maximizing quality and minimizing wastage. Maximizing quality and minimizing wastage. Right? Okay, maximizing quality, minimizing wastage, and it's a blend of 4 techniques that we have to discuss here. And remember, all these 4 techniques, these are independent topics, and you can always come across a separate question on each one of these. But whenever you come across the term lean production, these 4 have to be combined into the same answer. Right? And what are those techniques? Let's name them. Lean production includes flexible specialism, S-P-E-C-I-A-L-I-S-M. Lean production, like I said, it's a combination of four Japanese techniques that are used for maximizing quality and minimizing wastage. The first one, that is flexible specialism. It is further classified into three types. We'll discuss those afterwards. So the first technique that comes under the umbrella of lean production, that is flexible specialism, followed by JIT stock management, just-in-time stock management, JIT. Number one is flexible specialism, followed by just-in-time stock management, JIT. Very important topic, JIT stock management, just-in-time. We'll have a detailed discussion on JIT. So lean production is a combination of flexible specialism, JIT stock management, number three, it is called Kaizen. Kaizen, K-A-I-Z-E-N, Kaizen. Lean production is a combination of flexible specialism, just-in-time stock management. Number three, Kaizen. Obviously, it's not an English term. Literally, it means continuous improvement. Kaizen means continuous improvement. So the third technique included in lean production, that's Kaizen. And number four, we call it quality circles. Quality circles. Right? Quality circles, that is technique number four. So lean production is a combination of these four. I'm just going to give you an idea about flexible specialism. Learn a bit about flexible specialism, of course, and we'll continue with this in the next class also. So the first technique under discussion, that is called flexible specialism. So you see, the Japanese believe that if a business organization wishes to achieve long-term success, any business organization, if it wishes to achieve long-term success, then it has to show a high degree of flexibility. Right? If you want to be successful in the long run, you cannot be rigid. This is what they're saying. You can't be rigid. You have to be flexible in your approach. Right? And we all know what flexibility means. We'll be discussing various types of flexibility also next time. Because this flexible specialism, it is divided into numerical flexibility, functional flexibility, time flexibility. We will try and differentiate between all these. But for the time being, just the introduction. So Japanese suggest that any business organization that wants to achieve long-term success, and it wants to be there in the market, and it wants to be competitive and should be in a position to overcome competition also, it has to be flexible in its approach. It must not be rigid. A business organization that is rigid, it will never achieve long-term success. And we all know what flexibility means. You should know how to make adjustments. Flexibility means having the ability to make adjustments, assess the situation, the prevailing circumstances, and make adjustments. Do not be rigid. Otherwise, you won't be able to increase your market share. You won't be able to survive. You won't be able to overcome competition. Right? That's flexibility, a flexible specialism. So like I was saying, flexible specialism is classified into the following three. Just give the heading, first one. That's called numerical flexibility, dealing with numbers. Numerical flexibility. The first one is numerical flexibility, dealing with numbers. We are going to discuss numerical flexibility in detail in the next class that we have on Wednesday. We'll discuss this. But was another thing that you should note. We have a class on Thursday, the on-campus class, right? Section group 4. Because on Thursday and Friday, I won't be here, I won't be in Pakistan. So classes scheduled for Thursday and Friday will be rescheduled, and you will be informed shortly about there's going to be an online class in lieu of the classes that we were supposed to have on Thursday and Friday, since I won't be in the country. So you'll be informed regarding that. But we'll continue with this. We'll discuss numerical flexibility on Wednesday. That's when we have our next class. So just make sure you revise this. And lean production is an extremely important topic, especially JIT stock management is everywhere. And you go through the past papers, JIT, which is a part of lean production, very, very important. The entire topic actually is quite important. So we'll continue with this next time. All right. Allah Hafiz.